Alright, in the previous video we had looked at this actual data from an experiment and tried to determine, because we had made multiple measurements, to what place value we should record our average using the confidence procedure. And we had illustrated that we were confident down to the 10th place, but not to the 100th place. That means our average time for 10 oscillations should be recorded as 3.4 and not 3.35. Now, how does that translate into the period? The period is the time. Period is time for one oscillation. But this is the average time for 10 oscillations. So we can find the period by taking the amount of time for 10 oscillations and dividing by 10, which is the number of oscillations. So that's the time divided by the number of oscillations. And if you do that, the math out, you get 0.34. Because our confidence procedure suggested recording the average of 10 oscillations to the nearest tenth, we record the time for one oscillation to the nearest hundredth, as shown here. In other words, once we get this recorded correctly, then that comes out correct anyway, and so our period should be 0.34 seconds. And that shows the proper amount of accuracy, the proper confidence in our measurement, down to the hundredth place of the period. Now, a point to note is that the confidence procedure is carried out. The confidence procedure applies across a given data point, but not between data points. That wouldn't make much sense. So, as you're applying the confidence procedure to various actual experiments that we carry out rather than just problems on paper, make sure you're applying it to a given data point and not across data points. Now, one other note about actual experiments, we are going to assume that whatever the place value we should record our average to will be true for all of the data we collect. So there won't be any requirement to do the confidence procedure on this data and then on this data and then on this data. Once we do it here, then we will know that all of our data should be recorded to the 10th place. So this would be recorded actually as 4.2 seconds. And the same thing would be true with this data when we filled it in. And again, this would be 0.42 seconds. So the confidence procedure, in summary, is a way to capture the amount of accuracy or confidence we have in a measurement when we make multiple measurements, because the maximum capability of a measuring tool, ruler or stopwatch or scale, might not actually give us a proper sense of that place value that we need to record. You need to use the confidence procedure anytime you make multiple measurements. Multiple measurements will be made when you expect a lot of variability, and that's exactly the purpose of the confidence procedure, is to take that variability and allow us to write a number down that captures how confident we are given that variability.